Greetings to all. Today in this lecture we will learn about the relationship between the Bohr's postulate of angular momentum and de-Broglie wavelength. As we know that de-Broglie was the first scientist who had explained the dual character of the electromagnetic radiations, and this is also the application of the de-Broglie wavelength or de-Broglie concept. From the de-Broglie concept or de-Broglie relationship, we can also calculate the angular momentum of the electron or the angular momentum of the orbit. According to the Bohr's postulate, we know that only those orbits are possible which have angular momentum integral multiple of h by 2 pi. Around the nucleus, only those orbits are possible which are having angular momentum, that is mvr, the product of mass, velocity and perpendicular distance is equal to nh by 2 pi, where n is any integer, h is Planck's constant, 2 is constant, pi is also constant. Let's see how do we prove that this relationship occurs from the de-Broglie concept. If all the particles or electrons, they have dual character means they have particle nature as well as wave nature, then this is the Bohr's orbit having radius r, and electrons are revolving in this orbit. As electrons have dual character, particle character as well as wave character, if electrons they have wave character, then they will move like this. In this orbit, in this circular orbit, all the electrons they will move like a wave, like this. This is the wavelength of the wave. Now, according to the de-Broglie concept, wavelength is equal to h upon mv, where m is the mass of the electron and v is the velocity by which it is revolving around the nucleus. This is according to de-Broglie concept. Also, if we want to find the circumference of this orbit with the radius r, the circumference of the orbit is equal to 2 pi r, and this circumference is equal to n into lambda, where n is the number of the waves which are possible in this orbit and lambda is the distance of one wave, or also known as the wavelength. If the electrons are revolving in this orbit like a wave character, then this wavelength or the circumference of this orbit is equal to n into lambda, where n is the number of waves which are possible in this orbit. From this equation, this is the equation first and this is equation second. Lambda is equal to 2 pi r upon m is equal to lambda, or also you can write here lambda is equal to 2 pi r upon m. This is equation number third. Now compare these two equations, first and third, in which we have calculated the value of wavelength, as these two are the wavelength for the electron which are revolving in a particular orbit. By comparing these two equations, we get H is equal to H upon mv is equal to 2 pi r upon n. Let this is the equation 4. From equation 4, NH by cross multiplying NH upon mv is equal to 2 pi r. By rearranging this equation, we get NH upon 2 pi is equal to mvr, which is the Bohr's postulate. By rearranging this equation, this is the equation 5th. By rearranging the equation 5th, we get NH upon 2 pi is equal to mvr, which is the Bohr's postulate. According to this postulate, only those orbits are permitted which are having angular momentum integral multiple of the h by 2 pi. From de-Broglie relation, we can also calculate this postulate of the Bohr's. I hope this concept is clear to all of you.